In this chapter, we will apply scientific procedures to test the validity of our statement about population parameter. For your information, there are many types of tests if you want to validate your hypothesis or your statement. In this chapter, we will focus on the first types of test, which is known as one sample test of hypothesis. There are two things that we will focus in this chapter. The first one is 6 steps in conducting our hypothesis, and the second one we will focus on 1 and 2 tail tests. In particular, we will focus on Z and T distribution. Okay? You will learn all these learning objectives except the last one. So we will not cover the last one. So I'm expecting my student to be able to explain the process of hypothesis testing. You should also be able to apply the 6 steps to test your hypothesis. You can distinguish between one tail and two tail tests, and you can conduct a test of hypothesis about population mean. You should be able to compute it and interpret p-values and use t-statistics to test your hypothesis. Hypothesis testing. So basically, you just want to test your hypothesis. So what is this hypothesis? Hypothesis is just a statement or assumptions or just a mere claim about your population parameter. Since it is just a claim, so you have to verify it, you have to validate it, or you have to check it whether it is true or not true. Okay, as you know that it is very costly for us to find out the population value. So normally we will select our sample, and then based on our sample we will come out with our hypothesis or statement. Okay, for instance, you want to study about the academic performance of IIM students, right? So your statement or your claim is that, well, perhaps all IIM students are very smart. So you have to check it, you have to test it whether your claim is true or not true. So how do you want to check it? How do you want to verify it? You have to follow all the scientific procedures in hypothesis testing. The objectives of hypothesis testing is to verify our statement or claim about the population parameter. So in order for us to verify or to validate our statement about population parameter, we have to conduct 6 steps in hypothesis testing. So step number 1, we have to state the null hypothesis and alternate or alternative hypothesis. So you have to write your H null and H1. So H1 here refers to your alternate hypothesis. Step number 2, we have to select the level of significance. So level of significance can be represented by alpha. So your alpha can range from 0 until 1. So step number 3, we have to identify the test statistics. So for your information, we have many types of test statistics. However, for this chapter, we will be focusing on 2 tests. We have z-test and t-test. Step number 4, we have to formulate a decision rule. So in order for you to formulate the decision rule, we will use critical value, or we can say CV or PV. You can use either of them. Step number 5, we have to make a decision. So you can say whether you reject the hash null, or you cannot reject or do not reject the hash null. Step number 6, or your last step, you will interpret the result. Okay? Let's look at the details of all the 6 steps processed in hypothesis testing. So step number 1, you have to state the null hypothesis or hash null as well as alternate hypothesis, the hash 1. So what is null hypothesis? It is a statement about the population parameter developed for the purpose of testing our numerical evidence. So in other words, we can say that our hash null here is just a general statement or a mere claim made by anyone about everything. So because of that, we have to test it. So normally the null hypothesis always consists of equal signs. So you can see here we have equals, bigger or equals, smaller or equals. So how about alternate hypothesis? It is a statement that is accepted if the sample data provides sufficient evidence that the null hypothesis is actually false. Okay, so in other words, your H1 here is basically our own statement that we made because we have collected our sample data and we have provided sufficient evidence that the hash null is actually false. Okay, normally the alternate hypothesis never include the equal signs. So if you look at here, you have not equals, you have smaller or bigger. So let's look at the previous example when I said all IIUM students are very smart. So let me write it here. IIUM students are very smart, right? So if we want to convert this statement into a statistical form, I can write it here. IIUM students are actually very smart. Okay, so if you look at this statement, does it belong to hash null or does it belong to hash 1? So if you look at this sign equals, so it should belongs to your hash null. So how to write your hash 1? So you can say here, not all IIUM students are actually very smart. Okay. Step number 2, we have to select the level of significance, in this case our alpha. So alpha is the probability of rejecting the null hypothesis or our hash null when hash null is true. So sometimes we call alpha as the level of risk. Why is that? Because it is the risk that we have to take when we reject the hash null when the hash null is really true. So the value of alpha can range between 0 and 1. However, normally the researcher love to use the alpha value equals to 0.05, 0.01 or 0.10. So it is up to the researcher which value they will love to choose. Okay, but for your case, you don't have to worry about the value of alpha because alpha will be given in the question. Since you know that we cannot study the whole item in the population, so there is a possibility for us to make an error. There are two types of error. The first one we call it type 1 error. In this type 1 error, we reject the null hypothesis or hash null when the hash null is true. Okay, so type 1 error is represented by alpha. Type 2 error is that when we do not reject the null hypothesis when your null hypothesis is false. So this type 2 error is represented by beta. So let's look at this table. You have a few scenarios. The first scenario, your hash null is true, right? So when you do not reject the true hash null, you are making correct decision. But if let's say you reject the hash null when the hash null is true, you are actually making type 1 error. So the second scenario, your hash null is false, right? So if let's say you do not reject the false hash null, you are making type 2 error. But if let's say you reject the false hash null, you are making a correct decision. Okay, this is just the introductions of the possible error that you can make. Step number 3, you have to select the test statistics. So in this case, we will cover z-test and t-test. You know that you have to use z-test if let's say your population standard deviation is known. If let's say your sigma is not known, you have to use t-test. Okay? Step number 4, we have to formulate the decision rule. So what is this decision rule? It is a statement of specific condition, whether you want to reject the hash null or you do not reject the hash null. So how do you want to decide whether to reject or do not reject it? So we have to use critical value, or we call it CV. Critical value is the dividing point between the region where the null hypothesis is rejected and the region where it is not rejected. So we will look at the detail in the next slide. Okay? In this slide, I will not tell you on how to find the critical value or CV. We will discuss about it in other slide. So this is just the introductions of your CV. So let's assume that you find your CV equals to 1.645. So how do you know that your CV should be on the left side of your diagram or on the right side? Okay, for your information, the CV should follow the sign of your hash 1. So let me write it here. You have hash null and hash 1. So hash null should always contain equal sign. You can have equal, smaller or equals, bigger or equals. So how about your hash 1? Your hash 1 should not contain equal sign. You can have smaller, you can have bigger or not equals. Okay. If let's say your hash 1 is smaller, right? You have smaller here. So how do you plot the CV? So your CV should be on the left side of your diagram. So this is perhaps your CV, and you have to shade here. This is your rejection region. Okay, what happened if let's say your hash null is bigger? So this is your CV on the right side of your diagram, and this shaded area is your rejection region. Okay, what happened if let's say your h1 is not equal? If let's say it is not equal, so your CV should be in both sides of your diagram. You can have on the left side as well as on the right side. Okay, so later when you compute your test statistic, you can use T or you can use Z statistic, and this test statistic fall under the rejection region. You can say that you have to reject hash null. If let's say this test statistic fall outside the rejection region, perhaps here, so you can say that do not reject the hash null. Okay, so your CV will tell you the rejection region. If let's say your test statistic fall under rejection region, you have to reject your hash null. If it is not falling under rejection region, you shouldn't reject your hash null. Okay, that is the functions of your CV. So step number 5, you have to make a decision whether you want to reject your hash null or you do not reject your hash null. So how do you want to decide it? You have to compare the value of your test statistics. So in this case, you have Z, or you can use T statistic, and you compare them with your CV, right? So if let's say I want to draw a diagram, okay, so you know that for instance your CV is on the right side. Okay, so this is called as rejection region. Okay, and then your test statistics, perhaps you want to use Z, and your Z fall inside the rejection region. So this is Z. So you can conclude, you can make a decision. You said reject hash null. Suddenly, if let's say your Z is outside the rejection region, so you can say do not reject your hash null. As simple as that. And step number 6, or last step, you have to interpret your result. What can you say or what can you report based on the result that you get from the statistical test? Okay. When you draw a diagram, you know that you're going to have two tails, but sometimes you just want to focus on one side of the diagram, so you call it one tail test. But in some cases, you want to focus on two sides of the diagram, so you call it two tail test. So let's look at the examples of one tail test. So the first example here, how do you want to decide whether it is one tail or two tail? So you have to look at the sign of your h1. In this case, you have less. So less here means you are talking about one tail test, but it is on the left side of the diagram. So if you look at the examples number 3, so your h1 here is more. So more means you have to look at the one side of the diagram, but it is on the right side. But let's say the second example, your h1 here is not equal. So not equals here means that you are interested to look at two sides of the diagram. So you have on the left side as well as on the right side. And as you know that the total area inside your normal distribution should equals to 1. So this is just like your probability distribution. Okay. This is the example for two-tail test when your sigma or population standard deviation is known. Okay, so I always tell my students, whenever you get the question for hypothesis testing, you have to decide two things. The first one, whether you are talking about one-tail test or two-tail test. Second, whether the sigma or population standard deviation is given. If let's say sigma is given, you have to use Z distribution. If let's say sigma is not given, then you have to use T distribution. So let's look at this question. Okay, so this steel company manufactures and assembles desks and other office equipment at several plants in New York State. Okay, so at the Fredonia plant, the weekly productions of the desks follow a normal distribution with a means of 200 and a standard deviations of 16. So here you have the standard deviation. You have to decide whether this is your sigma or small s. So if you look at this question, it says that at the Fredonia plant, the weekly productions of the desk with a means of whatever 200. So you are talking about the whole productions of desk in Fredonia plant. So you are talking about the population. So your standard deviation here is your population standard deviation, and your mean here is your mu. Okay, so new production method have been introduced, and the vice presidents would like to investigate whether there has been a change in weekly productions of the model. Okay, so is the mean number of deaths produced different from 200 at the 0.01 significant level? Okay, so the question asks you whether the mean or your mu is actually different. So what is this different? Different is not equal from 200. Okay, so what is this not equal? Does it belongs to your one tail test or does it belong to two tail test? As I mentioned in the previous slide, when we talk about one tail test, so your sign may be smaller than something, or we can say smaller than 200 or bigger than 200. So this is the examples of one tail test. Okay, we can also say lesser than 200 or bigger than 200. This is the examples of one tail test. But if let's say we talk about different, which is not equal, this is the examples of two tail test. Okay, now you have answered your two questions. So let's start with designing our 6 steps of hypothesis testing. So the first step, you have to state your null hypothesis and alternate hypothesis. Okay, for your information, we should always start with H1. Okay, because H1 is your own hypothesis, or we can say that you have the evidence to say that your H1 is supported by evidence. Okay, you always have to start with H1, and normally H1 will be given in the question. H null is just a general claim made by anyone else, so you don't know whether this claim is true or not true. So you have to start with your own claim, which is H1. So what is your H1? It should be given in the question. What is the question says? Is the mean number of deaths produced different from 200? So you are talking about the mu, because we have said different, not equals to 200. So this is your H1. So after writing your H1, you have to write your H null. So how to write your H null? It is very easy. Normally, the H null will somehow follow your H1, but it has a different sign. So if let's say your H1 is actually not equal, so you can see that the mu is not equal to 200. So your H null should be the opposite sign. So not equal will be equal. Okay, if let's say your H1, maybe your mu smaller than something, smaller than 200. So your H null, the mu should be bigger. So it should be the opposite sign. And remember, for H null, you have equal sign. So it should be the opposite and contain equal sign. If let's say your H1 here bigger than 200, so your H null should be smaller and equal sign 200. Okay, as simple as that. Second step, you have to select the level of significance. Here, the level of significance is given, which is 0.01. Okay, step number 3, you have to select the test statistics. So you know that the sigma or the population standard deviation is given. So you have to use Z distribution. Okay. Step number 4, you have to formulate the decision rule. So in order for you to formulate the decision rule, definitely you have to find the value of your critical value or your CV. So how to find the CV? You have to look at T table. Okay, and the next step, you have to see the level of significance for two tail tests. So level of significance for two tail tests. Why do you have to look at two tail test? Because we are talking about two tail example. Next one, you have to find the value of 0.01. So this is your alpha. The next one, you have to go to infinity. Why do we have to go to infinity? Because we are using Z distribution. When we are using Z distribution, we are assuming that we are dealing with such a very large number. So we have to go to infinity. And these steps will give you the value of your CV, which is equals to 2.576. Okay, so in this case, because we are talking about two tail tests, so your CV will contain plus minus value. Okay, so you can see in the diagram, you have on the left side and you also have on the right side. Okay, how do you know that whether your CV has plus minus or just plus value or negative values? Okay, as I mentioned in the previous slide, your CV will follow the sign of your H1. Okay, so if let's say your H1 is smaller, means that it is on the left side of your diagram. So your CV will contain negative sign, right? If let's say your H1 is bigger, so we are looking at on the right side of your diagram. So your CV will contain positive values. If let's say your H1 is not equal, so basically we are talking about two sides of your diagram. So your CV will contain plus minus values. Okay, now let's try to formulate the decision rule because you have computed your CV. Okay, so how to formulate the decision rule? You should say reject your H null, right? If the next step, you have to write your test statistics. If let's say you are using Z, then write Z. If let's say you are using T, then you can write T. So here we are using Z. If Z, so you can see your CV area, right? So if Z smaller, then what is the left side? Negative 2.576, or your Z bigger than, what is the value? 2.576. So this is how you want to formulate your decision rule. Okay? Step number 4, you have to make a decision whether you want to reject the H null or you cannot reject your H null. So how to make a decision? You have to compare the value of your test statistics with your CV or critical value. Okay, the computations of your Z statistic should be done in step number 3. Okay, so let's assume that you know how to compute your Z and your Z is equals to 1.547. The next steps, you have to draw a diagram, right? And your CV is these two areas. So this is your rejection region. So what is the value for your first rejection region? You got negative 2.576 and here plus 2.576. Okay, so what is the value of your Z? So your Z statistics is 1.547. So 1.547 is somewhere here. So this is your Z. So it is outside your rejection region. So what is your decision? Do not reject your H null because your Z doesn't fall under the rejection region. If let's say your Z fall under the rejection region, so you should say reject H null. Okay, so the next steps you have to interpret your result. So how can you interpret your result? So because you cannot reject your H null, so you should say we fail to show that the population mean has changed from 200 per week. Okay? This is the overview of the 6 steps in hypothesis testing, and I'm expecting my students to be able to show your working in this form. So the first steps, you have to write your H null as well as H1, right? So you should start writing using your H1 because H1 is your own claim, and normally H1 will be given in the question. So what is our H1? The mu is different from 200 dash. And what is our H null? H null should be the opposite sign of our H1. So mu is equals to 200 dash. Second step, you have to write your alpha. Alpha equals to 0.01. Okay, step number 3, you have to compute your test statistics. You can use t-test or you can use z-test. But in this case, since the sigma is given, you have to use z statistics. So z equals to x bar minus your mu over sigma divided with square root of n. So by applying this formula, you should get the value of your z equals to 1.547. So step number 4, you have to compute your CV. Okay, because we are talking about two-tailed test, so your CV should contain plus minus value, and in this case your CV is equals to 2.576. So how to compute your CV? You have to look at t-table, and then two-tail test, and then your alpha equals to 0.01 and the infinity sign. Why are we looking at infinity? Because we are using z distribution. The next step, you have to draw your diagram, right? Okay, so you know that our CV is two values. So you have the negative sign, negative 2.576, and you have plus 2.576. Okay, so this shaded area is called as rejection region. Okay, so where is our z value? You have to plot it in this diagram. So your z value is somewhere here, which is 1.547. Okay, some of you may love to formulate the decision rule, but in this case, if let's say the question asks you just to show the 6 steps, so writing the CV is enough, unless the question asks to formulate the decision rule. Okay, so the next one, you have to write step number 5. So what is step number 5? You have to make a decision. So what is your decision? Since your z value is outside the rejection region, so you should say do not reject your H null. If let's say your z value is inside the rejection region, you should say reject H null. Next, step number 6, interpret your result. So how do you interpret it? In this case, we cannot reject our H null. Okay, so we should say we failed actually to prove that or to show that our claim is true. So we failed to prove that the mu is actually different from 200 dash. Okay, but what if let's say our decision is we reject the H null? So let's say our decision is reject H null. So we should interpret that the mu is actually different from 200 dash. Okay? So let's look at the examples of one-tail test. Okay, when we talk about one-tail test, it means that you wanted to look at one side of your diagram. Suppose the vice presidents wanted to know if there had been an increase. So in this case, the keyword is increase. The question can also ask about decrease, or larger, or smaller, lesser, or bigger. So if you look at here, increase means that you wanted to look at the right side of your diagram. If let's say the question asks about decrease, so you are referring to the left side of your diagram. Okay, so in this case, let's focus on your H1 because H1 is your own hypothesis because we are talking about increase. So the sign is actually bigger, right? So what happened? As I told you in the previous slide, when we talk about CV, so CV will always follow the sign of your own hypothesis or the sign of H1 because in this case, we are talking about increase. So your CV should be on the right side of your diagram. What happened if let's say the question asks about decrease? So decrease, your H1 will have the sign of smaller. So smaller will be on the left side of your diagram. If let's say you want to draw your critical value. The p-value or PV in hypothesis testings. So for your information, PV and CV serve the same purpose. That is, they will tell us whether we have to reject or do not reject our H null. However, in the case of CV, we have to compare our CV with test statistics. Right. While in the case of PV, we have to compare it with alpha, or we call it the level of significance. So PV has its own rule. So what is the rule says? So the first one, it says that if let's say your PV is smaller than the alpha, our decision is reject H null. If let's say the PV is larger than alpha, our decision is do not reject the H null. Okay, so What is this PV actually? PV is the probability of observing a sample value as extreme as or more extreme than the value observed, given that the null hypothesis is true. So you don't really have to worry about the definitions of PV. As long as you know how to apply the PV rules, so that is sufficient for you. Okay. So since you know that PV and CV serve the same purpose, so you can choose whether you want to use PV or CV. Okay? How to find your P value? We will use the previous examples on this production, and we have computed our Z value, which is equals to 1.547. You have to round it up into 2 decimal points. You will get the value of 1.55. Now, we want to convert our Z value into the probability. So you have to refer to Z table. And this will give us the value of 0.4394. And this value refers to this area, 0.4394. And our P value is this shaded area. Let me write it here, this shaded area. So how to find your P value? You know that half of this diagram will give us the value of 0.5. And then to find this shaded area, you have to minus with 0.4394. And this will give us the value of 0.0600. Okay, since we are talking about 2 tail tests, you have to multiply with 2. And this will give us the value of 0.1212. If let's say we are using 1 tail test, you don't have to multiply with 2. Okay, now our P value is equals to 0.1212, and we have to compare it with alpha, and the alpha is 0.01. And we know here that our PV is bigger than our alpha. And what is our decision? We have to say, do not reject the H null. That's it. Okay. Hypothesis testing when the sigma or your population standard deviation is not given or unknown. So in this case, you know that you have to use T statistics or T distribution. And we have learned about T distribution in the previous chapter. So this is like a revisions of what we have learned. So T distribution is a continuous distribution. It has a bell-shaped curve and symmetrical. And there is a family of T distribution depending on the number of degree of freedom, or we can say our DF here. And T distribution is a bit flatter and more spread out compared to your normal distribution. So let's look at the examples of hypothesis testing when your sigma or population standard deviation is not given. There are so many things here. I will just go straight away to the question. To evaluate the cost-cutting measure, a random sample was taken of 26 claims. So we are talking about sample, isn't it? So when we talk about sample, there is no way for you to know the population standard deviation. Because of that, you have to use T statistics. The next one, at the 0.01 significance level, is it reasonable to conclude that the mean cost to process a claim is now less than $60? So in this case, if you look at the words less, it refers to one tail test, or we can say that it looks at the left side of your diagram. Okay, now after having all this information, you should proceed with your 6 steps of hypothesis testing. So the first step is that you have to write your H null and H1, and you know that you have to start with H1. So how to write your H1? You have to read the question. Is it reasonable to conclude the mean? So we are talking about the mean, which is less than $60. So your mu lesser than 60. And how about your H null? So the H null should be the opposite sign of your H1 and also contain the equal sign. So mu should be bigger or lesser than 60. Okay? Step number 2, you have to select your alpha. Step number 3, you have to compute your test statistics. In this case, you will use T statistics. Step 4, you have to formulate your decision rule. Step 5, you have to make a decision. And the last step, you have to interpret your result. So in the next slide, I will somehow write all these 6 steps in detail. Okay? Let's write the 6 steps of hypothesis testing for T statistics. Step number 1, we have to write the H null and H1. What is our H1? Mu is less than 60. H null is just the opposite signs of our H1 and contain the equal sign. Mu is bigger and equals to 60. Step number 2, we have to write the alpha. Alpha is equals to 0.01. Step number 3, we have to compute the T statistic. In this case, we are using T statistics. What is the formula to compute T statistics? X bar minus mu over small s divided with square root of n. What is this small s? It refers to our sample standard deviation, and the formula to compute this small s is equals to square root of summations of x minus x bar squared over n minus 1. Given all this information, we should get the value of our t equals to negative 1.82. Next step, step number 4. We have to compute the CV. Remember, CV will follow the signs of our H1. In this case, H1 is less. CV should contain the negative sign, and the value of our CV is equals to negative 2.485. How can we get this value? We have a few steps to find the CV. We have to look at one tail test. Then alpha equals to 0.01. Next, the degree of freedom, which is n minus 1. Our n is 26. Minus 1, we will get the value of 25. Given all these steps, we should get the value of our CV equals to 2.485. Next step, we have to draw our diagram nicely. Right. In the middle is 0. CV is negative. We should look at from the left sides of our diagram, which is negative 2.485. This shaded area is called as rejection region. Where is our t value? It should be somewhere here. T equals to negative 1.82. The next steps, step number 5, we have to make a decision. What is our decision? We should say do not reject the H null. Why is that? Because the t value fall outside the rejection region. Step number 6, we have to interpret our result. What should we say? We should say we failed to show that our H1 is true. H1 is mu is less than 60. So these are all the 6 steps in hypothesis testing. Another point that I would like to share with you is that, remember in the previous discussion, I told you that CV and PV will give us the same information. If let's say you don't want to use the CV, you can also use PV. Let me write it here. Step number 4, PV. If you want to use the PV, you have to refer to step number 3, test statistic. If let's say you are using Z statistics, you have to refer to Z table. If you are using T statistics, you have to refer to T table. In this case, we are using T table because we use T statistics. There are a few steps to find the P value or PV. The first step is degree of freedom, in this case 25, and then we have to find the T value, which is 1.82, and we have to refer to T table. If you refer to T table, given the degree of freedoms equals to 25 and the value of our T 1.82 should fall within these two range, which is 1.708 to 2.060. Okay, next, if you look up, you should find the level of significance for one tail test. Why do we have to refer to one tail test? Because if you look at our H1, it is less. It means that it is one tail test. And then you will get the value of 0.05 to 0.025. These two values are actually our PV. Let me write it here. 0.05 to 0.025 are our PV. If you want to use the PV, you have to compare it with the alpha. Our alpha is 0.01. In this case, the PV are bigger than our alpha. So our decision is that do not reject the H null. Okay? You can just ignore this slide and the following slide. Okay?